but it's the same thing. Whatever's on the numerator, and I'll use this one to show you, if you take a term and you raise it to the m over n power, the m is the exponent, so look over here in radical form. The m is the exponent in both cases, and the denominator is the root that you're taking. Okay? So when the numerator is 1, you don't see an exponent over here because it's technically just being raised to the first power. Does that make sense? Okay? So here's your big, this is it, I'll just do it more clearly. B to the m over n is the nth root of b to the m power, or that m can go on the outside, which I actually would almost recommend. You can take the nth root of b first and then raise that answer to the m power. So it can go in either order. Okay? Really, and I'll show you why. This one,
shelter in place has been lifted. Again, the shelter in place has been lifted.
this one is b to the m first, raised to the 1 over n power. This one is b to the 1 over n power first, raised to the m. Who can explain via exponent rules why those two expressions are the same? Elena?
Because you multiply them, and you could multiply either way.
Right. Multiplication is commutative, meaning 2 times 3 is the same as 3 times 2. So m times 1 over n is the same as 1 over n times m, which is why this m as your exponent can be written inside or outside. Okay? People always get confused which one goes, where. So sometimes people will confuse the m and the n. If it's helpful, maybe you want to write something like this. Denominator goes there, and then b to the numerator goes there. That might be more helpful. The denominator is the root out in front of the radical, or kind of nestled in the radical, I should say. So if I just look at A up top, that's just 5x to the 1/2 power. Is the 5 being raised to the 1/2 power? Absolutely not. It's just on the x. If I wanted the 5 raised to it, I would have put the 5x in parentheses. I didn't because the 5 was not underneath the radical. Yes? B is x to the 1/5 over 4. C is 7 over x to the 1/3. D is 5 over 3x to the 1/10. Are there any questions on those 4? Okay, if I jump to the next section, A through D, I actually have some exponents on there. What root is this technically? Square, so that's your denominator, x to the 7/2. B is x to the 6/4. Now, in cases like this, 6/4 being a fraction can be reduced, yes? 6/4 would be the same as x to the 3/2, which means that could be written as the square root of x to the 3rd. For the record, that 4 and that 6 can reduce in the same way as a fraction down to technically a 2 and a 3. That's called reducing the index, they call it, as opposed to reducing a fraction. This is called the index of 4, so you're reducing the index in a case like that. This one is really, if you do it in parts, it's x to the 1/2 first, then raised to the 6th power. And a half times 6 is 3, following your exponent rules. And then this one is going to be x, if we do it all in one step, x to the 10/3, because that index of 3 becomes the denominator. No, this is really what they're looking for. Because I just showed you that just to show you the radicals could be reduced, but the instructions are to rewrite the radical as an exponent. And sometimes they'll ask you to rewrite the exponent as a radical. Let's jump right to the back to like the Regents style questions. So I'll go to right to the bottom. Anytime you have a mixture, and we may have already seen this problem last week or 2 weeks ago when we first learned this briefly, but now we're doing it a little more in depth. Anytime there is a combo of exponents and radicals, we are to make everything in exponents first and foremost. And then we will follow our exponent rules to the end. So this radical needs to be changed to x to what power? Tess? I'm just following this rule. Nth root of x to the m becomes x to the m over n. So I want to take this radical and put it into exponential form. So x to what power? Okay, so your n that was here, where did it go in your fraction? The n that's right here, where is it in your fraction? In the top or the bottom? The bottom. So take that 3, and we're going to put that in the bottom. The 8 test that was the m in the m spot, do you see that? Went to the numerator. So x to the 8/3 is what that would be. And then in your denominator, it's already in exponent form, and we can just apply our first rule. When you raise a power to a power, you multiply. So 4 times a third is 4/3. I'm obviously working this direction. And then common bases being divided means I do what with the exponents? Subtract. 8/3 minus 4/3 is how many thirds? 4/3. So then the question is, what is the value of y? So if this all equaled x to the y, and now we have it down to here, what is the value of y? 4/3. Y equals 4/3. Any questions on that? Okay, we're going to go back up one more and do 6. Oh, Angie, what would that numerator look like as a fractional exponent? What over what? 5 over, that's technically a 2, right? When you're taking the square root. So 5 over 2. Yep, good job. And the denominator, Alexa, what would that be? X to the what? 7/4, right? The index here, the 4, is the denominator. Okay? Index, denominator. I don't know, they both have a D. I'm stretching. You just have to keep that straight, and there we are. Now, common basis, subtraction. 5/2 minus 7/4. Well, 5/2 is the same as 10/4. 10/4 minus 7/4 is how many fourths? 3/4. So I now have an answer in fractional form. Which one of these is the equivalent radical form to that? 1. Everyone see that? If it had been a negative 3/4, you guys, that negative exponent would have brought it to the denominator. So that would have been option 4. Okie doke. Jack, you're off the hook. I'm gonna throw you under the bus on Monday, okay? All right. It'll be our little secret, Chloe and Jack. And Elena. Yeah. I didn't forget. I obviously ran out of time. Jack has got a special treat for everyone on Monday. You might want to bring in like a bag of Halloween candy just to share with everyone, because you might get attacked by the end of the day. Just something to butter them up before they can give you their wrath. You decided that you guys needed to shed light on the fact that you guys